Right, Monday morning. Welcome again to this wonderfully warm theatre. I swear you'll appreciate it in winter. By the time you'll finish this course and never have to be in this theatre again. All right, good morning everyone. Hope you all had a good weekend. Welcome to week 3. Another exciting, I made another few typos of course. Thanks Ben for pointing it out. So Ben is replacing Sophia today, so you might not get hit on the head as much. Don't know.
I don't make any promises.
He doesn't, yeah. He told me he thinks it's more fun to hit people on the head, so it could go either way. So I'm sorry in advance if that's the case. Okay, so what did we do last week? We talked about a lot of things last week. We really got into it. We talked about if statements with conditionals. We looked at some logic statements that we could do to ask questions. We looped the loop. We did a loop inside a loop. We just did so many things. We also talked a little bit about scanf and checking for what it returns. We'll talk more about that as we go as well. And then we started to learn about structs and enums as well towards the end of Thursday. So we still couldn't quite go over, we still need to go over a little bit more to rehash a little bit of structs, a little bit of enums. And then today, how exciting, we're finally going to learn properly about functions, because so far you've just kind of heard me use the word function a lot, basically describe what a function is a number of times with actual elements of a function, talk about a procedure, and still not really do functions. So today we're actually going to talk about functions, use functions, and actually, actually play with functions. And then we're going to look at style of your code as well. So why do we style our code well? What does good style mean? How, what are the style guides that we want to follow when we write our code? Someone's saying, do we get marked on style in the final exam? That is such a good question. Whilst you do not get marked on style in the final exam, if I cannot read what you've written, I cannot give it any manual marks. So you kind of get marked on style by default, because same with assignments. If we cannot read what you are trying to code, we cannot manually mark what you're trying to code. It makes it much harder to actually see what you're trying to do. So in that sense, yeah.
Is all assignments and tests get manually marked?
So that's a very good question. So in the in-person lecture, we've just been asked if all the assignments and tests get manually marked. Not your problem sets. Problem sets get automatically marked. Your assignments will be manually marked for style. Specifically, there will be a style component of your mark. But also for those that couldn't get your program to compile, we do look at it manually as well to make sure that we can give you as many marks as possible. And your exams do get manually marked, again, because we're trying to give you as many marks as possible. So it is in your best interest to also have good style. Okay, so there we have it. That was good questions. Okay, live lecture code. Tom, thank you in the chat. And I made all the files available, but I forgot to actually make the lecture notes available, so that's good. But we fixed that right before the lecture. So I think let's first go and let's do a little rehash of structs and enums before we talk about functions. All right, so I've gone wild today. I can't be held up by VLab anymore. And I'm going to be having a very white screen here. So this doesn't look like what it looks like for you. I'm sorry. Yes, font. Font? Is that what you were saying with this? What is this? Slow claps. Thanks, Ben.
Happy to help.
Okay. Now, oh my God. It is so hot in here. How's this? Good? What about at the back? I guess you're sitting at the front. You're probably can you see at the back? I'll just assume yes until someone complains. Dark mode. Oh, God. Oh. my God, I'll just start VLab for now and I'll go back to this. And then I'll put my... Well, that went very well. Good. All right, I'll put my... Everyone is always into dark mode these days. Sometimes. I'm trying to keep you all awake. Quite a few people code in light mode, when it's 3 a.m. especially. Okay, fine. We're back on VLab. And it's already slowing down. Okay, so first of all, actually, I'm going to start rehash enums, and we'll just quickly go through enums. Okay, so who remembers anything exciting about enums? Who remembers? Who wants to rehash enums? How are we feeling? A shower of hands. Yep. Just one person, 2 people, 3 people. Yes, yes, come on, we want to rehash. Okay. All right, let's rehash. Okay, good spelling, excellent, strong point. All right, so what are enums and why do we use them? So enums are basically enumerated data types. So what that means is that you have some data and you're grouping it together into one related piece and you get automatic enumeration with it. So whatever it is that I define, it gets automatically assigned enumerated, so automatically assign numbers to it. Or I can force certain assignments as well if I want to, and we can look at it in a second. Now, what's the point of enums, you ask? Good question. There is a few points of enums. So far, what we're doing, I suppose, requires not very large pieces of data. Just keep watching the sweat just going down your forehead, and it's killing me. So far, we've had a few little hash defines, and you think, okay, well, why do we need an enum for it? Yeah, you don't particularly need an enum. You could just do a hash define and have it as a constant. But what an enum allows us to do as well is to group related pieces of information together into sort of one big constant bundle. And what that means is it makes your code more readable as well. Now, there is a lot more points, a point for enums when you have to group larger bits of information together. So things like computing error codes, you know, perhaps there is 50 or 60 of them, and you're grouping them all together in one enum. They also get automatically enumerated, so it makes it a lot easier to manage as well. So let's have a look at what we do with an enum, and then we can talk a little bit more about it. Okay, so the first thing we want to do is we want to define the enum. Okay, to define the enum, we use the keyword enum, and then we give it a name. What should we do? What does everyone feel like today? Everyone's half asleep. It's very hard to stay awake in the heat.
Days of the week.
Days of the week. That is what I was thinking, and I was like, surely I cannot do days of months. Let's go for the other boring one. Okay, let's do months. Anything more fun? Constellations, I don't know that many, so that would be a disaster for me. Hey? Oh, God. Okay, you're really testing my...
That was an easy one.
I'll go, I could do a few, but then I was...
Mercury.
Okay, okay, I'm just going to go with months because I really know the 12 months of the year. Okay, so I'm going to go down, and now inside the enum, we do our enums as capital letters. Wouldn't it be fun if I just got a month wrong now? Could well happen. That required too much thinking for what comes next. All right, how exciting. Here we go. Okay, so we've got this beautiful enum, and inside it is some definitions. So if I were to do that as hash defines, I would have 12 hash defines, and it will be hash define Jan, 0, hash define, I don't know, Feb, 1. So it would be 12 hash defines. It wouldn't be obvious that those hash defines are related together, whereas now that I've placed them inside an enum, what is happening is I've basically made the code more readable by saying as well that these 12 things relate to each other. They're all part of this one bigger thing. They are part of a month. And they should really be part of a year if we're to be honest, but month it is. And then they get automatically assigned, enumerated. So they get automatically, it starts from 0. So this is going to be 0, 1, 2, 3, and so on and so forth. I could throw the whole thing, out of whack. I could force it to start enumerating at 1. So what this will do is it will start at 1, and then it will go add 1 onto the next one, and so on and so forth. I could just go crazy and decide, okay, that's going to be 50. So it'll go 1, 2, 3, 4, 50, 51, 52, 53, 54, and so on and so forth. Okay, so then maybe I want to use some of this enum, okay? So I'll go enum month, and then I will want to declare a variable name for it. So let's have month name. And then I might, I don't know, assign month name to September, okay, which is one of the things inside my enum, and then I might print out. So remember that an enum is really kind of like an integer. It's enumerated. So it's going to go to a number as something that's assigned to it. Okay, so if we do that, and then we try printing. All right, so let's try and compile it now. And it's going to print out the month is 54, which it is because it's 50, 51, 52, 53, 54. So it's doing the enumeration, just showing you how it's working through it. Okay, let's say I now have an enum, and we kind of did this as well last time. If I say, okay, well, actually, I want this to be 1 as well. Who thinks this is possible?
No, it's not possible.
Not possible? Let's have a look. All right, let's compile it again. It's not complaining at me. Let me try running it again. Runs all right. So it is actually possible to have 2 of the same values, which can happen and can be useful, I'm sorry to say. But let's see what happens if I now have another enum. And let's say I'll have enum favorite months. Yep.
We can't access the lecture code.
That's correct, because I just made this one up. Let me give you some access. There you go, should be all right now. Okay, let's have favorite month, and inside favorite month, how exciting, I'm going to have, I don't know, what's my favorite month?
March.
March, okay. It's a random month to have as a favorite, but I like it. December. Oh, I feel like that's you're heading for the end. It's all going to be all right. December's always the best month. Okay, let's try this. Do you reckon I can have this? I've got 2 enums, and they have really similar definitions in them. well, the same, identical. What do we think? We've got a no over here. Does anyone else? Yes, no, maybe? Yeah, no? Okay, people don't know. They don't want to get it wrong now. It's all right to get it wrong. Asking all the important questions. Let's compile it. Let's save it first, maybe. That would be handy. Let's compile it again. No! Okay, error. Redefinition of March. Error. Redefinition of enumerated December. Okay? So you cannot have the same element inside two different enums. That's not going to work. That's not going to compile. That's not going to work for you either. Okay. Okay, someone asked, actually, it's a very good question on the chat, how do we print out the actual name of the month by inputting a number? So it's not an easy way to do it. It's a bit of a hack and a workaround and a few bits of things possible. The point of enumerations is to go one way, is to go to the number. So there's no easy way to actually get what they belong to. And the reason that we just use these names in code is to make it also more readable and more understandable. Yeah?
So considering that we can't have the same enum definition into different enum types, I guess, does that mean like an enum is essentially like a series of different?
So the question was, is it kind of, I'm just going to summarize it, is it fair to say that it's like a series of hash defines because you can't have the same definition of a month in two different enums? So it's not quite the same as a hash define, but you can think of it as a series of hash defines, but it's not the same because it's kind of played with differently in memory and stuff. But it is like a series of hash defines in the sense that that's why you can't have the same thing. It's like you're doing hash define December, and you can't do that because you're redefining it then.
Is that difference that you mentioned going to be significant to us in 1511?
No, not at all. No, just in 1511, really focus on making your codes like readable and kind of coding neatly first of all, and then as you go, you will care more about being a little bit more efficient as well. All right. Okay. Let's have a look then at functions. All right. So everyone has seen me talk about functions. You've been using functions already in the last 2 weeks. You've used printf, you've used scanf, which are all functions inside that standard input-output library. You have also been using the main function in here, int main void, and you've been returning something from it even, which is pretty exciting, without really sort of just having a formula for it still, without really understanding, maybe understanding what you're doing, some of you, maybe not understanding what we're doing. So let's have a look what a function definition is and what it means to have a function. So what's the point of functions? So in code, imagine if I write a program and it's got, I don't know, 1,000 lines of code, 2,000 lines of code, okay? Then a human's going to come along and going to read that code. Do you think it's going to be easy to, I mean, even 100 lines of code, do you think it's easy to read 100 lines of code, especially if I switch light mode on for you? What do you reckon? Can you do 100 lines? I mean, you could probably do it, but it'll take you a while to try to differentiate what's going on in that piece of code. 200 lines, you're starting to lose the plot a little bit. 1,000 lines, you're starting to lose the plot a lot. 10,000 lines, 100,000 lines, you're going to start to lose the plot completely. So giant sections of code are really hard to read and really hard to understand for a human. So one of the points of functions is to make code more readable yet again. So it creates a much nicer style. But what else it does is that it makes sure that you can reuse chunks of code as well. So you can call a function whenever you need it in code, and that means you don't need to write the same piece of code twice, 3 times, 4 times, 5 times. So there are certain things that we do in code quite a bit, and that means that we can reuse those functions just by calling them all the time. So usually if you need to do something in code more than once, you're going to make it into a function, and then you can use it whenever you want. So the point of a function, make it more readable, break down your code into more manageable chunks as well. The other thing that functions do is they make it much easier to debug your code because you can switch functions on and off just by commenting them out, so you can see where the error lies in particular, and that makes it a lot easier to fix it as well. So let's have a look if we can define a function. Okay, so a function has a few parts to it, and we've kind of talked a little bit about it. And the syntax for it is over here. That first int, that is going to be the type, the data type that you are returning. Okay, excellent. Then the next thing that you're going to list out is the name of the function. Okay. In probably an unsurprising maneuver, you want that name to be meaningful. Okay, excellent. And then the last thing in brackets, you're going to have some more things in here. Some more parameters, and what that's saying is what is going into the function. Okay? So you're saying what's going into the function, what's coming out of the function, and the name of the function, and that really gives you the definition of the function. So let's try and write a simple program that will calculate an area of a rectangle. And then we will try and use a function in that piece of code just to see how actually it all comes together. All right, so what are some things we need to do to write this type of program? What do we reckon? Okay, so if we're trying to calculate the area, we really want the length of it. Okay. I can spell, I swear. Okay, then we want to find out the width of the rectangle. Okay, great. Okay, then we want to actually calculate the area. And then we want to output the area. Yes, yep, okay. Does that sound okay? Everyone happy with that? Okay, we want to ask the user for some of these things because we want to have some flexibility. So I'm going to scan in the width, scan in the length, and then do some calculations with them. Okay, let's have a look. So we need to store the length and the width in somewhere. So I'm going to have a variable that will store the length. And I'm going to have a variable that will store the width. Okay, then I am going to have some prompts. To make things faster, I'm just going to ask for both of them at the same time. The lecterns just failed. No, it's powered off. It's coming back, maybe. Well, is it fine for the live stream? That's all I'm worried about.
Yeah, the live stream's fine.
Okay.
I think it's going from the...
Okay, so I'll prompt, please enter the length and the width, okay, off rectangle. I should say off the rectangle, but let's just keep it short and unreadable. Let's not do that. Let's actually do it off the rectangle. Okay, excellent. Now let's do some scanning in. I'm going to scan in a few things. So I'm going to scan in 2 digits because I assume they're just going to put in the length and the width. And that's going to be a bit exciting. Okay, so going to scan in, and I'm going to place the first into the length and the second one into the width. Great, fantastic. We will do some testing for errors in a second. Can someone tell me what can go wrong here?
They could enter something that's not
Yeah, perfect. So they could enter something that's not numbers. They could enter. So you need to do some error checking. Okay, we'll take care of that in a second. Okay, great, good. So now we've got some numbers. Now we're ready to do some maths. Okay, I really just want to calculate area now. Okay. And I'm just going to write calculate area for now, and then I'm going to print out some sort of result of that calculation. Okay, so this is a really good place to use perhaps a function, because then you might want to calculate an area of a shape more than once, and then you can just keep calling the function if you want in a bit of a loop, if you wanted to do that as well. So let's try and do this calculate area as a function. Okay, let's try and implement calculate area as a function. Okay, so what I will go and do is I'll go down here below my main, and I will have this function calculates area. Okay, let's do input, output, name of function. Okay, excellent. What do we think, if I have a function that will calculate area, what do you think will be the inputs into that function? Yeah, length and width, okay. Great, so I'm going to input length and width. That means I will be inputting two ints, an int and an int, because both of those are ints. We haven't said that they're doubles or anything. We can change it over as we go. What do you think will be the output? Will I be returning something to my main, any information? Yeah, I'll be returning an integer because I'll be returning the area so that it knows what's going on. So I'm going to return the area, which will also be an int. And then I will name my function. Perhaps I'll name it calculate area. I don't know, or calculate area. Okay, so I'm saying that my output is an int. And I will do that by saying I will return an int in my definition. So the first thing I'll say is int. Then I'll do the name of my function, which will be calculate area. And then in brackets, what I will do is I will say what is it that I'm giving this function as well. Okay. Now we've got the two inputs are length and width. So int length and int width. Those are the two things that I'm giving it. So when you are defining the function, so in your actual functional definition, you have to say what data types you're giving it, because it will check, right? But over here, when I call the function, all I have to do is give it two variables that are going to be ints. So I give it length and width, and it will check that's got to be ints because it's got to agree with what this is getting. It's getting an int, and that means I have to give it something that's an int and an int. Now, do we think, so here I have called them the same thing, length and int length, width and int width. Do we think that it's the same thing that's coming into the function? It is that variable name called length. No, lots of people are saying no. Some people are saying, I don't know why you're asking me this. So it is not the same thing. I could have anything here. As long as it's an int, I could have number 1 and number 2. And it's still going to work perfectly, because what it's doing is when it's calling the function on line 30, it's saying length and width. So whatever the numbers are here are being copied into these two variables over here that we are saying it's going to get. And we'll run through the code line by line so you can see what is actually happening. Okay, so now I've got it as number 1 and number 2, which are terrible variable names. So I'm just going to change it back to length and width, and then I'll show you, just to make a point, what happens. Okay, and so to calculate my area, what do I do with my length and width? Yeah, I'll multiply them. Okay, so I could do it two ways. I could say int area is equal to length times width. Okay, and then what does that mean I would return here? Area. Excellent. So I want to return an int. and that's going to actually come back and give some sort of answer, and that int is area. So that is one way to do it. I could also be super duper lazy and return length times width. And because that gives me, when I do that, the result of this gives me an int, I'm still returning an int, and it means I can do it in one line as well, and I don't need an extra variable that's going to live and die as well. So 2 ways to do it. Feel free to adopt whatever it is. Sometimes when you're just starting out in programming, it's much easier to just break it down into a few more statements. Again, we don't care about your efficiency, so feel free to break things down as much as needed and do them step by step. Okay, excellent. So now we've calculated the area here, and now we print out the area is %d, and I don't have a variable. So the return of this, when it's returned it hasn't stored it anywhere, which means that the return is now floating about, well, it's gone actually, it's not floating about. So I really want to save somewhere the result of this. So this function will run, and it will return whatever the output is, and it will store it inside this area. And now I can do this, and then let's try it, let's run it. Okay, so what does this error message mean? And you will get it a lot. You will see me get it a lot. This is one of my favorite things to do. Now if you remember in the last few weeks, what I've been saying is I've been saying C reads things starting from the top, line by line down. So when it gets to line 30 and it says, okay, int area is equal to calculate area something, it's like, well, what's calculate area? I've got no idea what that is. I literally do not know what's coming afterwards. I only know what's happened before it. So sometimes what you have seen is that we can just copy this function and put it on top of the main. We could do that. There are some people that do that, have all their functions on top. That's okay, I guess. But it does have some, it does have some issues, and that means that you have to know in which order you're using your functions as well, which is quite difficult to do when you're writing big, large programs. So what we do instead is we use something called a function prototype. So before your main function, you will include any function prototypes, which is just really letting C know that a function is coming. And all a function prototype is literally the top definition of your function. So it's this bit here. You'll take it and you'll put it up the top above the main. Okay, and then afterwards you'll put a semicolon to say this is the definition of a function. It is coming later on, so don't freak out when you see it. Okay, excellent. Let's try that. Okay, so let's run it again. Okay, now it compiles, and if I run it, okay, now it wants to lengthen the width. Let's do 5 and 6, and it's saying the area is 30, which is super exciting. Okay, so it's kind of working. Well, I mean, it is working, but we still are missing a few things, things like doing any error checking at all or anything like that. So how about we put in some error checking as well, and then we'll go try and do a harder example where we break out into a few functions as well, where I'll probably run out of time. Okay. How can we error check this scanf? Thoughts, ideas?
Make sure that scanf has returned to...
Yeah. Okay. So I'm expecting 2 things to be scanned in, and that means that I want to be successfully scanning in 2 things. So once I check for that, it will ensure that if I run this type of program and put in, I don't know, C6, it's going to not do that for me and just kind of have a very bad time. Okay, so I really only want to calculate the area if I have inside scanf scanned in correctly 2 things. 2 ways to do it, because we haven't learned how to do it as one yet. So I might have somewhere where I'm scanning in, where I'm storing the return of scanf. So I'll have an int scanf return, and it's going to place the output of the scanf function, which is an int. It's going to put it inside this variable here. And then I can say here, if scanf return is equal to 2, then I'm going to calculate my area. I'm going to have a serious problem here as well in a second. Okay. Now, do we reckon this is going to work beautifully? Okay. Everyone's like, I don't know. Is it? It might not. Feels like a loaded question. Hey?
Even though area isn't defined.
Yes, it's going to not work beautifully. It was a loaded question. So if I run it again, it's going to have a little field day with me. It's going to say, excuse me, you've got this situation here where you've got this area. You haven't used it anywhere. But then here you're calling an area, but actually that's not the same thing. And that's because when I declare a variable inside these little curly brackets, it's going to die on the outside of that curly bracket. So that variable is going to disappear. So I can't really do what I've done here. And that's because I've tried to reuse area when it doesn't exist. It's gone. Okay? So I could just, in this very simple thing, I could just place it on the inside as well. Okay, the other way that I can shorthand it as well is, right now I'm doing it like this, in 2 steps. I can also do it as 1 step as well, because the output, so I can say the area is %d, and as long as I'm returning a %d, it doesn't matter if what I do in here is call my function without actually having another variable to store the output of the function is. So I could call it in here, and I can give it my length and width, and it will do the same thing as doing it in 2 lines. Okay. How else can I fix this situation here? If I have an int area, what if I really want to have this printf outside? How could I have fixed it?
Initialize at the beginning?
Yeah. So the other thing I could have done is just had, and I'm going to put it in comments so I don't break the whole thing. I could have had an int area just outside so it's available to everything inside my function, not just inside those curly brackets. Okay? So it's a lot more available. Okay, excellent. Very good. Okay, how is that? How is simple functions? How is everyone feeling? Yeah, everyone's feeling okay? There's a few thumbs up. I can see a few thumbs up. The air conditioning's kicking in as well, so this feels a lot better. Great, it only took an hour. Okay, so now it probably makes a lot more sense. So when I have this return something, that means I'm returning to it, and it's called a function, and then a procedure is when I don't return anything. It's where I have a void over here when nothing is happening. We're going to have an example of that as we do the next set of functions. Yeah?
Another question. So the main is also a function, right?
Yeah.
So is the input for that always void, or does it ever take anything?
What a great question, okay? So the question is whether or not the input of main is always void, and the answer to that is it's not always, it can be, we can input parameters. We can take things from terminal and read them in, and then we change what's inside that bracket, and we will be looking at that after Flex Week. Yeah, so you can read from terminal straight away when you compile. Like when you compile, then you run the program and you give it some parameters, and you can read those in straight away. And there's other things that you can do as well. All right, excellent, very good questions. Okay, does anyone actually, just before we go, does anyone want me to run through it line by line? Or is everyone happy with it? Tom, can you run a poll? Everyone's schnoozy. Oh, look at that. A few people on the chat, they're not as shy as the people inside the theatre. Okay, let's run through it quickly, line by line. Okay, actually what I'm going to do is I'm going to make this screen a bit bigger, and then we're going to Okay, excellent. All right, so we go inside, we compile, we run our program, we go into the first line here, int length, and that means we create a variable called length of type int. Then we go on to the next line, int width. That means we create another variable of type int that is called width. We move to line 29, print out to terminal. Please enter the length and width of the rectangle. Let's say over here we're putting in 5 and 6. Okay, excellent. So now what I've got is I've put in 5 and 6. It's scanned them into length, the 5. That means 5 is going to go into length, and into width, the 6 is going to go. That means my scanf return, I've scanned in 2 ints. That is exactly what I told it I want to scan in. And that means inside my int scanf return, which is my other variable, I'm now going to have a 2 because I scanned in correctly into it. Excellent. I'm going to go to line 34 now and say if scanf return is equal to 2, so I'm comparing is 2 equal to 2? Yes, it is. Great. That means I'm going to go inside this bracket. I'm going to go to line 35. On line 35, I'm going to create another variable called area that is also an int. And what I'm going to do then is I'm going to call a function called calculate area, and I'm going to give it a variable length and width. Now the variable length is right now 5, so what I'm doing is I'm calling a function. So I'm going to call calculate area, and I'm going to give it 5, and I'm going to give it width, which is 6. So I'm going to give it a 5 and a 6. Now this is not going to be pretty because I have to scroll down a little bit, so it's not going to align as well. Okay, great. So I've called, I'm going to go looking for this function now. Here it is. Great. What's going to happen now, I've given it a 5 and a 6, which means what it's doing is it's taking its 5 and putting it in here. It's taking this 6 and it's putting it into here. Okay? And that means that these ones here, these variables, are using the ones in your definition of input. They're not using the ones that we defined over here. No, they're using these ones here. Okay? So now I've got area, and that means my function over here is different. So this is my main function here, and this is my calculate area function. So inside my calculate area function, I'm making a new variable called area. I'm also making a variable length, which is going to have the 5 in it, and I'm making a width, which is going to have 6 in it, and I'm making an area. Inside area, I'm saying, could you please do length times width, which is 30. I'm going to place it inside 30, and then I'm returning that number 30. Now, where that goes is it goes in here, and that means the result of this function is going to be 30. So now, inside this int area here, I'm going to assign it 30. So that's now going to get a 30, and then on line 36, I'm going to use whatever it was, the area in here. So I'm going to use this area, and it's going to go in here. So notice that the variables, even though they're called the same, they're different variables. They're just copies of whatever on earth we sent off to our functions. The two functions are running separately, and that's because of how they move onto the stack in memory. So if I just demonstrate that for you, so let's say, oh, that didn't erase any of that. Okay. Let's say what I'm going to do is I'm going to go back to calling it, I don't know, number 1 and number 2. Do you think that's going to work now? If I then have int area is equal to length times width, in here I'm saying number 1 and number 2. What do we reckon? No, it's not, okay? It doesn't know what length and width are. Length and width are over here. And they're variables that are available to the main. They're not available over here. So now, instead of doing length times width, what I should be doing is number 1 times number 2, because that's where I've stored the actual values for my length and my width. Okay, so now it will actually calculate the area and place it in here and then be able to return it. Otherwise, it's not actually able to do that calculation. Okay, how is everyone feeling about functions so far? Okay, not okay? More, less? Okay, Tom, can you do a poll, please? Thank you. Just how are we feeling about functions? Oh, sorry, there's a poll already in there. Okay. Not too bad. Okay, can we change the, in the live stream, sorry, can we have more zoom on the screen? Thank you. Okay, all right, now feels like a good time to take a 5-minute break on this point, and then we will return in 5 minutes, and then we will continue. right, let's come back with a fake Kahoot. All right. There's nowhere to charge you guys. But you can go here. Okay, let's do it. Now I can't switch on the lights either. Ah, music stop. Sorry, I can't switch on the lights. The lectern is frozen. So, do you want to manually turn them on? Thank you, Tom. Oh, and it didn't do the. I know. Oh. Well, just take a guess. That's really annoying. Okay, I'm going to move on from this question because it really did not do me, it just did not do me a solid. But if you look here, the two while loops, notice that there is no resetting of something. I mean, not that you can see it, it's completely cut off, but you know, whatever. Let's go to the next one. There we go. Back to the exciting music. Bit of practice with structs.
Oh wait, no, you can't.
Very glad to hear people were listening. Nope. Oh, same question. Let's see if you get it right this time if you got it wrong before.
Like, is it?
Oh, that's better. Oh my God, that's so tiny. I'm so sorry.
It bothers me how donut and donut is spelled. Struct donut.
Yeah, right?
Is that a thing?
Hey?
Is that a thing?
What?
Like, are they both valid spellings of
One's American. But yeah, it annoys me too. That's why it's there. So you don't like donuts? Oh. Monster.
Yeah.
Okay, look at that.
Let's go.
Tom? Or Ben? Ben is our guest. St. Elmo with a fire. So someone loves 80s music, 80s movies. There we go. That. Oh God, Tom. That was all right. Who was Kathy? Let's throw a few more around. Is there a Kathy in the room? No, no Kathy. No one is even pretending they're Kathy. Thomas? Are you Kathy?
No, I'm Thomas.
Oh, you're Thomas.
Well, we're Thomas.
I mean, he's more likely to be Thomas. That's his actual name. Anyone else in the room that's on the board? Yeah, just come on. There we go. All right, now that everyone's awake, let me lull you again into a soft sleep with some more functions. Okay, let's do some more functions and then we'll do some style. I thought maybe, should we do one more functions or do a bit of style? What are we feeling? Functions, style, functions, style. Functions. Someone's saying functions and they're the loudest voice because they're the only voice. So just go with functions for a bit more. And someone's saying style in there. We will do style, but let's do, style. Style is a fun one, but functions potentially the more, all right, let's do a bit of functions and then we will go back to style. And then on Thursday, we'll go back to functions again. It's really mixed. I don't know why. Yep. Okay, let's have a problem like this. A program that takes in 2 die rolls and checks whether the sum of the dice is equal to the target number. And you win if that's the case. Amazing. Otherwise, you can roll again. Okay, so how are we thinking we're going to solve this problem? What are we thinking? What are we feeling? What steps are we feeling?
A variable for the target number.
Yeah, do you think a variable for the target number? Pardon? Yeah, hash define, a constant. We do want, that is a very good, yes. Okay, so we want a hash define for a target number because we're assuming it's not going to change. Well, we hope it doesn't, otherwise you'll never win this game. What else are we going to do? Yeah, we will definitely have some if statements in there, but what's our high level overview of solving it? Yeah. Yeah, so we want to know, want to take in what is die 1, want to take in what is die 2. Then we might want to add them up. Okay, great. Anything else that we want to do? Is that it? What else can we do here? We probably need to do other things.
Error checking.
What?
Error checking.
We will need to do some error checking. Yep, somewhere in there for sure. What's another step that we would need to do? Well, output sum maybe, but
Sum's greater than the value.
yeah, we want to check what on earth is happening if we're at the target value or not. So we need to compare the sum to the target value so that we know if we've actually won or not. And then maybe here we will print out, did you win or did you get less than or greater than? Okay, great. Let's go with just this problem for now. We won't extend it to a loop. And then we can look at a loop maybe on Thursday and add a loop in as well. Okay, so let's hash define first. Okay, so I'll hash define in here. What should we have for our target number? What are we feeling? 7. Okay, let's do 7. Good. Okay, great. Now we need 2 dice that we're going to read in. So I'll have an int die 1 and I'll have an int die 2. Okay, excellent. There we go. For that person wanting to know when will the code update, I've just saved all the files, so it should update. Okay, and now let's scan in. So let's scan. Actually, we should probably ask the user first. So let's do a little prompt. Okay, and then we might scan it in. Okay, definitely not doing any error checking right now. I'm going to store the result of that scanf into die 1. Maybe I should just leave you to go off and do that. And then maybe we'll do what is the result of rolling die 2. I'm really desperate to type in due. Die 2. Okay, and then we'll scan in the second thing. And we will store it into our die2 variable. Okay, excellent. Maybe some error checking here as well. Okay, good. Okay, so we will come back to that. Good. Okay, so now what should we do? We've done 2 dice, and now what do we want to do? Let's add them, okay. Okay, sounds good. All right, add them. Let's do some dice. I'm going to do it as a function. Okay, so what do you think I will need to give my function some dice to be able to add 2 numbers together?
I wanted that too.
Yeah, I need to give it the 2 numbers to add together. Okay, so die1 and die2 are going to go to this function. So now let's try and make this function, okay? Okay, so my input will be the 2 dice, so die1 and die2 values, as you have told me, which means I'll have an int and an int coming into this function. Great. What do you think will be the output of the function? Pardon?
It'll be this, whatever the sum.
Yeah, whatever the sum is. What data type will that be? Int as well. Good. So this will be the sum of the 2, and that's going to be an int as well. And then I guess I've kind of went with the name already, and I called it sum dice, which is just, I should just call it sum of 2 numbers, because that's really what it's doing. Doesn't have to be dice. Okay, so let's define it. Output, yeah. In line 33, where should the int go? You mean up here? I mean to store the value of it into something? Or what are you? So, okay, so when I call the function, okay, I only need to refer to it by its name. Okay, so it's like you calling another person.
You can store it in a variable. You should store it.
Yeah, but if I don't store the output of this function in somewhere, that output will just disappear. So what I would need to do here is I would potentially need to have an int sum that I'm storing the output of this function into. Okay? And so what it does is it calls the function, it's going to go find the function, and when the function finishes, it returns to the same place from where it was called from and gives it whatever was returned at that same place. Okay, so in our function definition, we've got the name of the function, sum dice, and we know that we're giving it 2 things. We're giving it number 1, and we're giving it a number 2. Okay, I'm going to call it different things just so that you kind of get the feel for the fact that it's not the same thing in this case. It's making copies of whatever on earth you're sending to it. Okay, so we've got number 1 and number 2, and what we want to be doing is we want to be adding them together. Okay, so let's add them together. And I'm going to do it like this. I'm going to do return number 1 plus number 2. So the result of this is going to be an int, which is why I can do return and then this, because I'm actually still returning an int. Okay? Or you can do it in 2 lines as we did it in the example before that. Okay, great. So now what happens is that the function will return from where it was called from. So it will come back to line 33, and what it will have in here now is the result of this, and it will place it into my sum variable in here. So now I've got the sum, and now we've said, okay, now we've got the sum, we want to compare the sum to the target value. Okay, so now I want to see if it's less than, more than, or if it's equal to the target number. What do we reckon? I think it might also be a very good place to do a function. So let's do compare the sum as a function as well. So this is a very contrived use of functions here, because obviously I'm trying to kind of do as many functions as possible. they will feel a lot more organic and natural when you're doing, when you're running through your code as well. Okay, so I'm going to call it compare. What do I need to give it, do you reckon? This function that will compare the sum of it with a target number. What do you think I need to give it? 2 ints? Or I've already added them together.
No, I mean the target and the...
Do I need to give it the target? Aha. That's very good though, because I don't need to give it the target because my target is a hash define, which means it's available to everywhere in my whole file kind of thing. It's available outside of the main to any other function that I'm using. So that target is available to anything, which means that all I need to give it is the sum. I need to give it 1 int. Okay, great. So let's do this function here. So this function will compare the sum to the target number. Okay, excellent. And we have said that the input is going to be the sum, which is going to be 1 int. And the output, what will the output be in this case? Pardon? Integer. What will I return? 0 or 1 to tell me what?
1 equals true.
Okay, could well do, and then I could print in this. What if I wanted to, and absolutely you can do that, what if I wanted to print out, so what if I wanted this function and then print out if you are less than, greater than, or on the target? What if I was doing the print out straight in this function? What will I return? Nothing, yeah, exactly. Void. I'm not returning anything because I'm just printing out straight from there. Okay, so that's really why I wanted to do this, to show you that this is now going to be a procedure because it's returning nothing. Okay, and then the name is compare, spelt correctly. Okay, so I'm going to not return anything actually. So I'm going to return a void, which means I'm going to put void at the start, and that means I'm not returning anything. I don't need the keyword return in my function. So I'll have void. My name will be compare, but I'm giving it one thing. I'm giving it the sum. Okay, in here I will do my comparisons. So this is where I want to say, am I greater than the target, less than the target, or am I the target? Okay, great. So how do you think we will do that? What will we use? Yeah, let's do some if statements. Sounds good. Okay, so if my sum is greater than target, then I will print out okay. Then what will I do next? Will I do, what else will I, how will I chain it together? How will I check for the next thing?
Else
Yeah, okay, good. Else if. Sum is less than target. Okay, then we'll do a printf in here and we'll say the sum is less than the target number. Okay, and then how will I chain the next statement onto it? Yeah, okay. All right, great. Okay, excellent. Now I don't need to return anything. This really should be it, okay? Have I forgotten anything? Yeah, I have. Yep, good. Everyone's paying attention, I guess. That's good. Yeah, well done. I've forgotten my function prototypes. Okay, so function prototypes, I'm going to put them above the main, and then I'm going to use them to let C know they're coming. So I'll take that and Okay, so after my function prototype, I put a semicolon to also let it know what's going on. And then my other function was, okay, so I've got two functions coming. Yeah.
So like, does the order of them matter?
Excellent question. Okay, the question is, does the order of them matter? Okay, it doesn't really matter, but it's good style to kind of have them roughly in the order that you're using them, but it doesn't matter. You're just letting them know that they're coming. And that's one of the benefits of using function prototypes as well, is that they don't, if you had these functions, sum, dice, compare, above the main, they'd have to be in the, they might have to be in the order if in fact, if you call another function from a function, and then you'll get, you get bombarded by things. But in this way, they can be anywhere. They're just available because they're all being called from somewhere else down the bottom. So it doesn't matter then that their order. Okay, let's compile. Okay, and let's run it. Okay, let's do 4, let's do 5. The sum is greater than the target number, I agree. And then if I would go again, this is not very good because really is the target number amazing, but I'd have to like run the program each time. So it's not very flexible program. How can I break it? What do we reckon? Negative number? I mean, can you even have a negative number if you've rolled a die? I mean, it's going to work, but it's not really. We didn't do any error checking that the die is between 1 and 6. So that's something else that we would need to do in there as well. Okay, so somewhere in here, you would also want to do some error checking. That the die is between 1 and 6 as well. So quite a bit of error checking that's missing from here. I mean, I can obviously break it if I do characters. If I do, yeah. It will just stop, yeah. All right, very good. How are we going for time? Not bad, all right. How are we feeling about functions? We will keep using them a lot from now on, and you will use them in your assignment as well, which is going to be released next week. Your first assignment, so something to look forward to. Maybe. All right. Tom, can you just do a little poll for me? Thank you. Okay, let's look at style. Why not? I think you all need a little wusa break. Okay. I think I need a break after this. Hey? You don't like that? What do you mean? It's so fantastic. Yeah. Okay, what do you think of this? Beautiful. Is it easy to read? Is it easy to understand? Does anyone know what it's doing? Now, amazingly, I mean, I assume it works because it does compile. Okay, so it compiles no problem, but I don't really know what's going on in here, and it's very difficult to read. Now, if you do something like this in the exam, I'm not giving you any extra marks. I will not be able to read that. That's not going to happen. Okay? In your assignment as well, you're getting marked on style. Definitely don't do this. You have to really try and style your code in a way that will make it easy to read for a human. Okay, yeah.
In C, does indentation not matter in the same way that it does in something like Python?
Yeah. Indentation matters for readability, basically. Yeah, exactly. Indentation is, yeah. I mean, obviously, I have no indentation here, and I've got statements running across one line. Yeah. No, I can't hear you, sorry. In your code for the assignment, should you be using comments? Yes, you should have, but you should be using a reasonable amount of comments. What do you think of these comments over here? I think I may loop here. I'm not convinced here. Return 1 here. Do you think these are good comments? No. Is there any point to them? No, they just make it less readable. So those are not the types of comments that we want. And my lecture code is completely over-commented as well, okay? My lecture code is commented too much because I tried to make notes for you to come back and see what's going on later. So too much commenting. Comment where things are not obvious what's going on, and comment at the start of the function to say what the function is doing, and what inputs, outputs are. That's usually the kind of commenting that we do. And in chunks of code where something is very complex and it's not very clear what you're doing, or you're doing something, pretty fun and complex. Okay, what do you reckon would be the first thing I could fix here? Yeah. Yeah, I think the first thing you should be fixing is tabs, absolutely. Because that is always the easiest way to make something more readable. All right, here we go. I have, in the past, just broken the piece of code because sometimes it's easier to burn than to fix. Am I burning or am I fixing? We should do a poll for that. Should I burn it or should I fix it? Okay, so first of all, I'm going to give it a bit of space. How about these variable names? So good. Okay, what's going on over here on line 25? No, we can't do that. That's no good. Went from no tabs to too many. You do that, you will hurt my soul. Please don't ever do that. I'm starting to lose where it is. Okay, let's try this. Struggling, struggling, struggling. Okay, so look how I line up my curlies as well. I line them up with the statement that they're closing to make it easier to see where it is. Let's return this statement back. Yeah. Okay, some spaces as well between. Oh my God, this is hurting my soul. I shouldn't have done this. Where's the else? No, this is all right for now. That can't be right. Okay, what else can I fix? All right, what are some other suggestions? Yeah. Yep. Sounds good. All right, let's fix the spacing. So always have space around. Always have space around the equal signs.
Success. Line 26.
Oh gosh, yes. Yeah. So let's. Okay, so tidying it up. It's now looking better. Okay, so spaces first, indentation first, then spaces. And then what are we thinking will be next? Oh my God. Okay, what else do we think is a good one to fix? Do you still know what it's, oh, that's too much space. Do you know what it's doing? Yeah. Yeah. Lovely, okay. What else? Is this telling me much? What's going on? Okay, what about these ones here? Yeah. Okay, let's do that, and then we'll... Okay. How are we feeling about those? No, actually, you tell me what to fix next. Oh, this is...
Oh yeah. The enum needs to be uppercase, right?
It does, very good. I'm not going to change it yet just because I'll need to replace them all through, I think. But it's definitely, yes, this needs to be in uppercase. Okay, what else? What else would I fix next? Comments, let's get rid of these comments. I agree, let's get rid of them. They're useless and they're just really hurting. Maybe don't remove semicolons whilst you're there. Okay, great. What else can I do? The variable names, yes, they are terrible. They do not tell me at all what's going on, okay? Again, if I see this in an exam, I will not know what it is that you're doing. And whilst we're at it, what about the file name? Test.c. Does that tell you what on earth is going on in this file? No, shocking.
It tells us that you wrote the program.
Exactly, it tells you that I've written this code, especially because awkwardly there's a test2.c next to it, which has nothing to do with this lecture. All right, do as I do, not as I say. No, the other way around. Do as I say, not as I do. Okay, excellent. Let's change some of these variable names. What can we have? What do we reckon will be? Let's start with the struct. What do you think is happening just from the printf statements? What are we talking about here?
Calculate the price of an ice cream.
Yeah, it looks like we're trying to get the price of ice cream. Okay, so what do you reckon this struct is meant to be defining? Yeah, I think ice cream as well. So I might call it ice cream. Okay, now do we reckon that's a good variable name? Price would be better, I agree. And I should really just do a find and replace. Okay, good. And what else did we change? Oh no. Okay, we'll call that one. That's the only place where it would have gone. Okay, int port. I don't know whether. Pardon? Yeah, that looks good. I think it was meant to be portion, but. And what about char yum? Flavor maybe. Yeah, maybe. We'll see. Okay, so what have we got in here? Someone's saying, wouldn't it look better to put enums in one line? Yes, that's the way I do it. And then I looked at our style guide for this course, and that's not the way we recommend you do it in the style guide. So now the enums have gone over many lines. Depends how many definitions you have in the enum. Okay, so what else have we got? What else are we changing? So we've got scoops, flavor, excellent. in here we've got a loop, we've got in success, and that success is reading in from scanf. So what do you think is a better name for that variable, for example? Yeah, let's call it what it's actually doing. So it might be doing a scanf return for us, and that means we change it in here as well.
We have a variable that's just the definition.
Pardon?
The variable total price is just the one that you defined before.
Yeah. Yeah, it's not a very good variable name. I don't really know what it means. I actually don't remember what it means now either. I think I'm just wanting to use that ice cream. I don't know why it's tall. It's because I'm short.
The final price for IC with ice cream. You know
Oh
how
no, price cream. Oh, that's no good. Good spot, good, yeah. Potentially, yeah, okay, so here, okay, price is something happening here. What do you think OS can stand for? Operating system, I can see your brains going. Maybe one scoop. Okay, all right, good. What else can I fix? Anything else anyone wants to fix, or you feel like you've burnt this, it's done, you don't want to do this anymore? Oh God, there's just a lot of issues now because we've been fixing and not fixing it through. I haven't been replacing.
Why we should burn it?
Hey?
Why we should burn it?
I did. We should burn it, I feel. So this is what happens when you have a piece of code, and this is what's going to happen when you do your assignment. You're just going to go through, do whatever, just to finish the assignment, and then you'll think, oh, hang on. It's getting marked for style. I better go back and fix it. And you're going to have hours of this situation where it's going to be really, really, really hard to fix it. So please, 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 please do your style as you go. Code cleanly from the very beginning. Think about what variable names you're using. Think about indentation and spacing, and making sure that you code cleanly as you go to start with. Again, do as I say, not as I do. Because sometimes you get into a bit of a time lapse and you do not code cleanly. Do you code cleanly all the time, Ben? What about you, Tom? Of course. All right. Everyone's getting too rowdy during the style. I might go back to functions. That was a nice relief. Let's go back to functions. Actually, any questions about the style to start with, to finish with, to end with, anything? Style. Any style questions? No? So I expect to see very clean, beautiful code as I look through your submissions. Yeah. What an excellent question. Where should the comments be? Do not do inline comments. Always have them above what you're doing. So don't do comments that are going to go here and this is doing something. So don't do those types of inline comments. They are a bad practice because often they'll push you off the lines and they're not as easy to spot. Yeah. Very good question. Yeah. I can't hear. Hey, let's pipe down a little bit. I can't hear any questions. Yeah. I still can't hear. Ah, yes, of course you can. Yes, yes, yes. We don't leave you on your own. Style checker. Yeah. I mean, it breaks all the time, so we leave you a little bit on your own. But with a little security blanket that breaks a lot. All right. Okay, what else? Functions, should we do a little while loop somewhere? We haven't done a while loop today. I did not mean to do that. Let's do a while loop today. Where should we have a while loop in here? What do we reckon? Where should a while loop go if I wanted to not do? So if I compile it again, okay, so if it runs like this, where it asks for one die, asks for another, then it checks and it tells you if it's greater than or not, and then you have to run it again to do it again. But now I want it to keep guessing until it gets the right guess. Where will I have a loop? What do we reckon?
Before the print statement?
Before the print statements? The print statements are inside the
ones asking for the number.
Around everything.
Okay. So we want to loop in here. And what should our condition be? What do we reckon?
Correct, yes or no?
Okay, so I'm going to finish it here. And then I'm going to tab all of these statements over by one. Okay, so we're saying maybe let's have a flag. And if it's a target number, then we're going to change that flag. But how are we going to know that? Because now we've created this program where the comparing is done in a function, and it's printing out whether or not we're on target or not. So now we've got this setup that really kind of prevents us. Okay? Not this week. Give it 2 more weeks. Come on. Can we return something? We can return something. Absolutely. So we can return something from our compare function to make sure that it knows if it's hit the target or not. Okay? So let's return something. So now we're going to change it to return. To return an int if the sum is not equal to the target. Okay, great. So that means here now I'm going to return an int instead. And what's that int going to be? Int flag, I'm going to call it. Struggle Town. Okay. And so here we're going to return the flag. And here we're going to return the flag. And what happens if we hit the target? Should we return something else here? Yeah, let's just return 0 because we don't need to do anything. Okay, what's going to be an issue here right now? Yeah, flag's not initialized. It's not, there's nothing. I'm returning flag. That doesn't mean anything. So let's say flag is 0 or flag is equal to 1. And then I'll return flag here, I'll return flag here. I could return a flag here and make it equal to 0 as well, but returning 0 kind of does that anyway. Okay, great. So then here I would check what my flag is equal to, and I'm going to have an issue again. And I want to check that flag is equal to 1 because that means that it's not the target number. Okay. And if it's equal to 1, then I'm going to go on and I'm going to scan it in again. I'm going to sum and I'm going to compare. And then I'll go back and I'll check again. OK, but what's happening here? I'm not saving the return anywhere either. So that's going to be a bit of a problem for me. This whole theatre is a problem for me. No aircon, no lights. I don't know what's going to happen next. Okay, over here I'm also trying to check for a flag, but I don't have a variable of the name flag, so not sure where I'm getting this variable. So let's declare a variable here. And this is getting real messy, okay. Now I want it to go into my while loop, so I'm going to make flag equal to 1 to start with. That means it's going to go into this while loop, and it's going to do everything inside this while loop, which is going to be very exciting. And then I'm going to take the output of this compare function and put it inside flag as well, for now. Everyone's starting to really lose the plot, I think. Let's just run it one more time and then we can rehash it. We can have a little early mark and we can rehash it on Thursday as well. Thank you. Did not change the definition. Good, good, good. First mistake. Okay, so my definition's changed. Let's try compiling again. Okay, now it compiles. Let's see what happens when it runs. Okay, so now you could be here forever, or you will finish. Okay, so it's not very nice though. It's not very efficient code, but it works kind of. And we can look at it and run through it line by line on Thursday when we start. So if you have any feedback from today, not the heat, I seem to not be able to do anything about the heat, but let me know as well, too fast, too slow. A few people are saying too hard. Don't worry, we will keep going through it. We will keep rehashing. But thank you for putting up with the heat again. It might not get better for the rest of the term. Hope you have a good rest of the week. Thank you.